Okay, 14.6, special right triangles. We're going to look at two very specific right triangles and how you can use the proportions given to you from the book to figure out the lengths of the side of these special right triangles. The first special right triangle is a right triangle that has these equal angles here, this 45-45 right triangle. We call it a 45-45 right triangle. And there are ratios that the book has shown you that every 45-45 right triangle has. So it doesn't matter. You can make this a very big 45-45 right triangle, and it still will have these same ratios or proportions, no matter how big or small that right triangle is. And these are what they are. This side, let's say this side is A length. So any length, it could be 1 inch, could be 25 inches. A, if this is A, then this side is also A. So that's telling you that these are always going to be equal. If it's a 45-45 right triangle, then the two legs are always going to be the same, A and A. The hypotenuse, then, this longer side, which is always across from the right angle, is A times square root of 2. Those are the proportions that a 45-45 right triangle will always have. Okay, and I will apply that in just a minute. But let's first look at one other special right triangle that's called a 30-60 right triangle. Remember, all the angles add up to 180 in a triangle, and so we have 60 and 30 here, 90, and then 90, 180. In this special right triangle, there are also ratios or proportions involved in each of these sides. It's a little different. This, if we could say this is A, in the 45-45, you had both those sides were the same. Not so in a 30-60 right triangle. If this is A, then the hypotenuse is double that. Okay? If the short leg is A, the hypotenuse is 2A. And then down here, the other leg has a square root of 3 times that A. So they all have that A. This one's just A. This is double the A. And this is A times square root 3. And as long as we can remember these proportions that they give us for these special triangles, we can figure out some cool things with the right triangles. So again, the 45-45 right is A square root 2, and the 30-60 right is A square root 3, and the hypotenuse 2A. And this is how that's useful for us. This will also be on the helpful handout that I gave you. You can use that as you do your homework, this helpful handout. Right in the middle, those proportions are all right here that you can use for special right triangles. All right. So let's utilize that information that we just learned, and let's do these up here. Let's try to figure out some sides. First of all, they give us this 45-45 right, so right away we look here. This is what we want to use to help us get answers. Well, this makes sense, doesn't it? This side is 2, and this side is 2. Well, that makes sense because they're supposed to be the same. If this side and this side are 2, and these are both A, this is just A square root 2. So all you have to do is take A and multiply it by square root 2. So in this situation, you just take A, which happens to be 2, and multiply it by square root 2, because this is 2, it's 2 square root 2, right? I was writing the answer, but this is A square root 2. Just substitute what A is in. So your answer is 2 square root 2. You can give it in this answer and not decimal form. Just leave it in this answer is completely fine. They will ask you for decimal form if they want it. Okay, so that's a really easy one. And what about this one? This is kind of reverse. Okay, they're saying, well, if this is 5 square root 2, what is this? Well, look here. A square root 2. 5 square root 2. Well, what is A? You have the square root 2 here, so A has to be 5. and these two sides are a. So these two sides have to be 5. So x equals 5. And here x equals 2 square root 2. So those are kind of simpler ones where you just have to compare and contrast, and we'll get a little more tricky here in a minute. Now let's look at the other two. Those are 30-60 rights. So you would use your helpful handout to help you compare these. Here's our 30-60 right proportions that we wrote. I would suggest that you turn it or rewrite it the right way because it's confusing. It's easy to flip them, okay? So what I'm going to do is I'm going to just sketch one here, and I'm going to put on it the right places, what proportions I want. I always make my A look like a 9. There. Now, you see I'm not going to get mixed up because it's the same as my other ones. So let's see. This is A, right? 3 is A. The hypotenuse is 2 A's. So 2 A's here would be 2 times 3, which would be 6. So x will equal 6. All right. Now, this is A square root 3. Well, we know what A is. A is 3. So y would just be 3 square root 3. Simple as that. Let's try this one. All right, so we don't know our A in this situation, or x, right? But we do know that the hypotenuse is 8. And we know that the ratio, proportions over here, this is 2 times A. Well, 2 times A, if that's 8, what is A? Let's see, let's get rid of 2 here. Cancels it, and it makes it A is equal to 4. Okay, which makes sense. 2 times 4 is 8. So if this is 8, this down here has to be 4. Now, if we have our A, right, our A is down here, and that's 4, then our long leg is A square root 3. So if this is our A, it's just that square root 3. So those are fairly simple. You'll have a few of those, and then you'll have a couple that are like this that are maybe a little bit more involved. So let's try a couple like this. Okay, so they give you a triangle, and they tell you it's a 45, 45, 90. So let's take your helpful handout out and have your ratios ready. And then let's try to solve something. Well, this one's fairly simple, actually, even this one yet, because we already have this square root 2 here, right? Because don't forget, this is the hypotenuse. It's just flipped over. So if you want to, you could hold your helpful handout there, so it's the right way, right? Excuse me. This is A square root 2. So 5 is A. So basically, these are 5, right? See how easy that one is? All right, let's do one that's not as easy. I think this next one might be a little harder. Again, my little helpful handout is not the right way. So I'm either going to want to hold it upside down, which you could do, and make sure I get the right ratios in the right spot. All right, this one you might have to work through a little bit. We have only this one is given. We have to find 2 other sides. Well, 12.4 we know is 2A. Right? 2A. So if you know that, make it equal, and then just solve for A. I'm sorry, you can't see what I'm doing. There. So now we make it equal because we know that the proportion here is 2A, and we know what it is there. So we start there, and if we just make our equation, then we just solve for A, because we got to find out what A is to find. Everyone needs an A. So if we know A, we can figure them all out. So we divide by 2 both sides, and we're going to get A equals 6.2. It drops the 2. So now we know A equals 6.2. We know A is just simply this, so x is 6.2. And now we know y is A times So y is equal to a times square root 3, right? Because that's the proportion here. So y is equal to that. We know a now, so we can say y is equal to 6.2 times the square root of 3. Now, in your book on these, where you're going to just keep going and not leave a square root, it will tell you, I think it makes you use 1.732 for square root 3. Instead of using your square root button, they want you to use this. So let's do that here. Let's do 6.2. Wow, that was sloppy. Times 1.732. That's my y. If I do that, 6.2 times 1.732, it's going to equal 10.7, and I think it goes to a thousandths. We'll make it a thousandths. So that would be your y. So that is pretty self-explanatory there. You got your a, you got your y, and this a becomes your x, right? So a lot of those. I think that should be sufficient for you. Let's see if we want to do one more just to make sure. If we have this one, let's get our helpful handout back out. This one matches ours. Okay, and we'll just do this quickly, the same thing. This one, we have 9.4 is our a square root 3. Okay. Now our a here is y, right? But we need to figure this out first. We need to get rid of the square root so we can solve for a. To do that, we're just going to divide both sides by n. And remember, we're using 1.732 for square root 3. This is going to cancel, so we don't need to do anything with that. But we do need to know this, 9.4 divided by 1.732, and it comes up to a equaling 5.427. So we have our a. That is going to go here, right? Because that's where it is here. That's where that belongs. Okay? Now our x here is our 2a. Well, we know our a. So all we do is take that, we already have on our calculator, and multiply it by 2 because this is 2a, right? Now, if you needed to see that, x would be 2a equals, if we substitute a in, 2 times 5,427, right? And that would equal 10. Well, mine I didn't round off because I used my calculator. Let's make sure. Yeah, 10.854. Okay, so that would be my x here. All right, those are your trig ratios that you can use, or not trig ratios, I'm sorry, your ratios, proportions that you can use on 30-60 right triangles and 45-45 right triangles. And you can use them consistently across the board with special right triangles. Tomorrow you'll get into those trig ratios that I mentioned. All right, go to it.